Damu Education. If not yet subscribed, please subscribe and click the bell icon. So in this session, we are going to discuss our seventh question. A hemisphere is curved from one face of cubical wooden block such that the diameter of the hemisphere. So what is the diameter of the hemisphere will be? So this one will be diameter of the hemisphere will be the equal to side of the cube. Let's going to take side of the cube will be A. So what is the argument? So determine the total surface area of the remaining solid. So actually, so we need to take this block here. What is the total surface area of the solid? So diameter of say hemisphere will be equal to length of the side of the cube. So side of the cube. So let's take cube side will be A. So let's take cube side will be equal to A. That means diameter will be equal to A. Then radius will be equal to T by 2. That means A by 2. So this is the radius of the hemisphere. What we need to find it here? The finded length will be equal to what is that? So we need to subtract from this. So what is this? So this is the area occupied. So what is this? This is the area occupied hemisphere. Let's going to write it this way. What is the total surface area? So total surface area of solid will be equal to all faces. How many faces in the cube will be? So front and back and left and right 4 and down will be one more face will be there. How it is? It will be like this. So if you divide like this, the solid will be like this. So this is the cube. So for top and so front, back one face and left, right one face and bottom will be 4 faces. So 5 faces. Area of surface area of 5 faces of cube plus inner surface area of the hemisphere. What you can say here is inner surface. So this all surface of the hemisphere you can take it. Inner surface bowl, it will be like bowl. So that surface we need to take it. So inner surface area of hemisphere. Then what is the next one? So hemisphere plus what you can say, we need to subtract from the top face of the cube and circle surface. So what you need to take it here is, so surface area of, we taken as ABCD as surface area of face ABCD. So ABCD minus, we need to subtract the circle area. So inscribed, what is that? Circle top face. So this circle area we need to subtract from this top. So this area. So area of circle of hemisphere. So area of circle on the top face. Area of circle on the top face. So this one is the total surface area of the given solid. So let's going to find out each one thing. So first one, let's going to take it. What is that? So surface area of face. So surface area of face of the cube. Face of the cube will be equal to what is that? That is length into breadth. That will be equal to front one, whatever it is. So all are equal for that. A into A, that will be equal to A square. Then surface area of 5 faces other than top 5 into A square, that is 5A square. So first one we are calculated. What is the next one? Inner surface area of hemisphere. So inner surface area of hemisphere will be equal to what is that? Hemisphere will be 2 pi r square. That will be equal to 2 into pi into r square is what? A by 2 whole square. We can get it as 2 pi A by A square by 4. 2 1s are, then 2 2s are. That will be equal to pi A square by 2. So pi A square by 2. So this is the value, we got it. Next one. Third one, what we need to find it is area of ABCD. That will be equal to top face. So area of ABCD, surface area of ABCD minus area of circle. So area of circle which described on the top face. area of ABCD is nothing but a square, that is a into a, all the dimensions are equal, then circle area will be pi r square. That will be equal to a square minus pi into a by 2 whole square, radius we are already calculated, a square minus pi a square by 4. So this is the value. Let's find out what is the required, what is that required total surface area. So total surface area will be equal to, total surface area of solid will be equal to area of that is 5 faces, that is 5a square plus pi a square by 2. What is that? Here we need to take it to the inner surface plus a square minus pi a square by 4. So this one we have to take it 5a square plus pi a square by 2 plus a square minus of pi a square by 4. What we can take it here? We can take it as a common 2 pi a square by 2, and so what is that? We can get it as here pi a square by 2 and write it one place. So 5a square that is 6a square. Then what you can take it here, pi a square by 2 minus pi a square by 4. So let's going to take LCM of all these things. Then what you can take it here is, so let's going to take this one 6a square plus pi a square by 2 minus pi a square by 4. So that is the value we got it here. So let's going to take it pi a square by 2 minus pi a square by 4. So let's going to simplify with the LCM. So let's going to do this one 6a square. Let's take this only for these two LCMs. So we'll take it least common multiple is 4, then 2 pi a square minus pi a square. So this value we will get it here. Why? Because here why we are multiplying, LCM is 4. In order to get 4 here, so in order to multiply 2 2s are 4, for that we are multiplied at top. So 6a square plus 2 pi a square minus pi a square is pi a square by 4. So let's going to take a square as a common. So what we can take it here, a square as a common means a square into 6 plus pi by 4. So 6 plus pi by 4. What is this? This one is the square centimeter. So like this we have to find it, or you can take it as